طيب بسم الله الرحمن الرحيم والصلاة والسلام على رسول الله الأمين وأشرف الخلق أجمعين. السلام عليكم ورحمة الله. In this video, so far we have discussed about the demodulation of AM, in which we have discussed the envelope detector especially, and left the square law demodulated as an assignment to be submitted by a student before the end of this semester. Students should understand the principal operation of the square law demodulators and their mathematical representation. So in this video, we will solve some problems or questions from the envelope or regarding the envelope detection or detector. So the first question says that an AM signal, an amplitude signal, is detected using an envelope detector. The carrier frequency and modulating signal frequency are 1 megahertz and 2 kilohertz respectively. An appropriate value for the time constant of the envelope detector is asking about the time constant tau or RC time constant of the capacitor, so that the envelope detector can detect the AM signal and recover the message signal perfectly. And we have 4 choices. You have to choose one of these answers. So let's see the solution, and then we can pick the right answer according to our solution. طيب, we have FC is equal to 1 megahertz, 1 times 10 to the power 6 megahertz, and FM is equal to 2 times 10 to the power 3 kilohertz in hertz. So we know that for the detection, or for the envelope detector to detect the AM signal perfectly without any distortions, this requirement should be met. That means the time constant RC should be much greater than 1 over FC, where FC is the carrier frequency, and should be much less than the reciprocal of the message or modulating or baseband or information signal, FM, or the message signal for simplicity. So let us, and we have FC and we have FM. So we just need to replace the values and see the values. So 1 over 10 to the power 6 is much less than RC, is much less than 1 divided by 2 times 20, 2 times 10 to the power 3. So we replace FMB by 2 to the power 3, and FC, we replace it by 1 times 10 to the power 6. So if we made this calculation, so we can just raise the denominator value 10 to the power 6 in the numerator up here, then we will get 10 to the power minus 6 plus, it becomes minus, less than RC, 10 to the power 3 positive. In the numerator it will get be negative, 10 to the power minus 3, and we have 2 here. So if we multiply here this side, the right hand side, by 10 to the power minus 3 and divided by 10 minus 3, so we will get, this is a microsecond, and much less than RC, much than, and half will become 5, so this value will become 500 microsecond. Then the appropriate time constant should be selected for this optimal condition, as we know. So if we take this value, RC should be much less, greater than 1 microsecond, and should be much less than 500 microsecond. Let us see the answers. So 500 microsecond, 20 microsecond, and 0.2 microsecond, and 1 microsecond. So the value should be in the range of much greater than 1 microsecond. Let us see the first one. 500 microsecond. So these values, 500 microsecond, is not appropriate because RC should be much less than 500 microsecond. So 0.2 microsecond 0.2 microsecond. That means this value is less than 1 microsecond, and RC should be much greater than 1 microsecond. So this value is not correct. And 1 microsecond, let us see, and RC should be much greater than 1 microsecond. So it is not appropriate. So the appropriate value is 20 microsecond, because 20 microsecond in the range of it's much greater than 1 microsecond and much less than 500 microsecond, and this is optimal condition for this detector to demodulate the AM signal using the envelope detector without distortion. So this is the first question solution. So this is question number 2. A message signal M of t is equal to cosine 2000 pi t plus 4 cosine 4000 pi t. This message modulates the carrier signal C of t is equal to cosine 2 pi fc t, where fc is equal to 1 megahertz. So we have fc is equal to 1 megahertz. To produce an AM signal or modulated signal, for demodulating the generated AM signal using an envelope detector, the time constant RC of the detector circuit should satisfy one of these answers or one of these conditions. Let us see which condition will be the correct one by solving this problem and solving the questions. So first, let us see the message signal that is going to modulate the carrier, the amplitude of the carrier signal. The message signal expression is cosine 2000 pi t plus 4 cosine 4000 pi t. If you notice, this signal is not a single tone signal or wave. This is, we call it multi-tone because it has more than one frequency. And when the signal has more than one frequency, we call it multi-tone signal or multi-tone signal or wave. So M of t is equal to cosine 2000 pi t plus 4 cosine 4000 pi t. So we have two frequencies in this message signal. So Fm, whether it is F1, 1 kilohertz, and F2 is 2 kilohertz. If you know that this is equal to 2 pi fct omega. So we can get the frequency from 2 pi fc, then it is 1 kilohertz here, and here it is 2 kilohertz. And we know that from the questions we have in the fc is equal to 1 megahertz. So this is all the requirements that we have. Fc is equal to 1 megahertz. That means it's equal to 1 times 10 to the power 6. So just using again the optimal condition for the time constant that for the envelope detector to detect the AM signal without any distortion, it should be RC is much greater than 1 over FC and much less than 1 over FM. So we have now here FM, we have to select between these two ones. Then, as we said, we know that FM is the maximum frequency component of the signal. And in case of multi-tone, then we have more than frequencies. Then we select here, the idea here to select the maximum frequency, which is 2 kilohertz. This will be considered the FM, not F1. It's not going to be considered as the FM. The maximum of this frequency, if you have another term and another frequencies, then we have to see the maximum frequency among all of these frequencies exist in the multi-tone signal. So then just we replace these values here, 3 kilohertz. Here we know that this is FC because RC is much greater than 1 over FC, and this is FC is equal to 1 megahertz, 1 times 10 to the power 6, and much less than 2 times 10 to the power 3 because this is the maximum. This is bigger than the 2 kilohertz, and this is 1 kilohertz. That's why we use Fm is equal to 2 times 10 to the power 3. So replacing this will be 1 microsecond. We take this up here in the numerator, and it will become 10 to the power minus 6, and 10 to the power minus 6 is a micro, so this will become 1 microsecond. It's much less than RC and much less than, and this is up here will become 10 to the power minus 3, and this will be milli, and this is half, so it is 0.5 millisecond. So if we see the answers here, we find that the correct answer is A. The correct answer is B, because RC is much greater than 1 microsecond and much less than millisecond. So this is the correct answer. Question number 3, consider the amplitude modulated AM signal AC cosine omega CT plus 2 cosine omega MT cosine omega C for demodulating the signal using envelope detector. The minimum value of AC should be 2 or 1.5 or 0. You have to choose the minimum value of the carrier amplitude, or the amplitude of the carrier signal. So let us see, this is the modulated wave. So accordingly, S of t is given by AC cosine omega CT plus 2 cosine omega MT cosine omega CT. This is given by this is a modulated wave. So for demodulating the signal using envelope detector, we have two conditions, as we know, and as we have discussed, and as we have learned. The first one is the optimal condition, that the time constant should be much greater than 1 over Fc and much less than 1 over Fm, where Fc is the carrier frequency and Fm is the message or modulating or baseband signal. And the second condition, the amplitude modulated wave, the modulation index should be less than or equal to 1. If mu, which is the modulation index, is greater than 1, then the envelope detector cannot detect the signal. And here we need to demodulate the signal using envelope detector. And hence, the question is to find the minimum value of the amplitude of the carrier signal, and we have to select one of these answers. Let us see which one is the correct answer. So, if we meet this condition, then we can know which one is the correct answer. So, this is a standard amplitude modulated signal. Okay? So, quickly, the standard form, or you can put this in the standard form. So, we can take AC cosine omega CT outside, so it will become AC cosine omega C outside, and it will become 1 plus 2 over AC cosine omega MT. For single tone, so this is for single tone modulation, we know that the standard form, as we know, S of t, this is a standard expression for AM, and for single tone is equal to AC 1 plus mu cosine omega MT cosine omega CT, where mu is the modulation index. So if we compare equation number 1 and equation number 2, so we will find that 2 over AC is the modulation index mu. And we know that mu should be, less than 1, so that the envelope detector can detect and extract the information from the AM signal. So, according to this condition, this is a mu here in the question, 2 over AC, which is here, should be less or equal to 1, or from here we can find AC is greater than or equal to 2. So the minimum value of AC is, AC minimum should be 2. So if we go here to find the answer, the minimum value of AC should be 2 or greater, definitely. But he asked about the minimum. That's why we get it here. It's greater than or equal to 2. Okay. Before to conclude, this question has been left as an exercise for the student. And the question is the amplitude modulated wave, S of t is equal to AC 1 plus Ka M of t cosine omega CT is fed to an ideal envelope detector. The maximum magnitude of the Ka sub MT is greater than 1, which of the following should be the detector output. I hope that to find the answer in the Telegram Thank you very much. And